Well, with some basics of probability out of the way, we need to get a little bit more precise information if we're going to be able to use this at all in terms of our statistics. And one of the things that we want to define is the term events. What do we mean by events and how do we count them? Because counting events and being able to figure out the number of ways that an event can occur is going to be central to the way that we determine how a probability is going to affect us. So, in this section, we'll talk about events. Now, a couple of things that we want to know. We talk about a sample space and event. A sample space is a collection of all of the possible outcomes. In our last video, we talked about finding the probability that we got a certain card or set of cards from a deck of 52 playing cards. So if we talked about a sample space, right, if we're doing a experiment of just pulling cards out of a deck, our sample space is the deck of cards. That is, it is all of the possible cards that we could get from that deck of 52. An event is a collection of outcomes for the experiment. That is, any subset of that sample space. So if I was talking about my deck of cards, for example, any subset of that sample space could be if we pulled a heart, or if we pulled not a club, or if we pulled any other event, if we just said the five of diamonds. Whatever event that occurs, that is what we're talking about, the number of ways that that experiment can come out, right? So we talk about the event, we're talking about an event occurs only if an outcome of experiment is a member of that event. Very often when we talk about probabilities and we talk about the ways that we count them, it's handy to use what we call a Venn diagram. A Venn diagram is a way of indicating parts of a population or parts of a group, a sample space, that meet certain events, right? So for example, if this box right here, very part A right here, this box represents the entire sample space. So my deck of 52 cards. And I said the event not E, right? So let's say the event was not pulling a club. Well, that event E, represented by the white space, we darken in the space that is not E. So we say the event not E right here, right, means that any event that falls outside of that group of possible events, E, right? Another event that we could talk about is the event A and B. That is, if we have two subsets and we had a set that fell within those two sets, then we could call that the event A and B together, right? So if we had a red card that was less than 10, right, for example, let's talk about that, right? In our deck of 52 cards, if we had a red card that was less than 10, well, there are two possible ways to get red cards, right? We could get hearts and we can get diamonds, right? So we could get hearts or we could get diamonds, right? But there was only a certain subset that were either hearts or diamonds and were less than 10, right? So that is cards that are red and are less than 10 would be in this group right here, right? If we talk A or B, we could talk about two groups that could have something in common, right? And those events could overlap, right? But we say that events A or B would be represented by the darkened in circles that included everything in both sets right here. So here are some relationships that are really handy to know. If we say the words not E, we're saying, well, everything but that particular event occurs, right? If we say A and B, both A and B occur, and they have to be at the same time, right? So both A and B have to be true. Something that is in A but not in B wouldn't fit, and vice versa. By the way, the event A or B means that either both A or B or both could occur. So that's what we mean by this particular logic. A couple other phrases that are really, really handy to know. At least A, right? If we use the words at least, we mean greater than or equal to that event A. So for example, when we talked about our example in the last video, where we said the number of families that were at least 3 or at least 4, right? we mean that those events could be something greater than. Now, if we say at least, that means we could include that endpoint. If we say more than, right, then that's another mathematical way of stating the events that are going to include those events or more, right? At most is sort of the opposite, means less than or equal to B. And between A and B inclusive means greater than A, but possibly equal to A, but or less than and possibly equal to B, right? So the word inclusive means that we're including the endpoints. If we use the word exclusive, right? If you were to see the word exclusive, it would mean that we exclude the endpoints. So that would be more like events that fall between A and B but do not include A or B, right? So we have a little bit of a difference there. All right, we'll use these terms here in a minute. Let's talk about dice, right? Dice are a really good kind of probability experiment, certainly. So we talk about our 6 outcomes. Well, here they are, right? This actually makes up our sample space, right? We consider this group of values that we can get from our dice to be sample space. So since I'm not going to be writing dice, right, I'm going to say, well, what are the all possible events? Well, the sample space here is we roll a 1, 2, 3, 4, 5, or 6. Okay, so this is now my sample space. And we're interested in the sample space and counting the number of ways that certain events could occur. So let's say the event A is that dice comes up even. Well, how many ways can event A occur? Well, we know that event A occurs in 3 ways. Right? There's 3 even numbers in the sample space. How about this one? The event of the die comes up 4 or more. What does that mean? Well, the event B can happen in 3 ways also, right? Because there are 4, 5, and 6. So there's 3 ways that we can get a die to come up 4 or more. C, the event of the die comes up at most 2. So what would that mean? Well, in event C, right, at most 2, that means that either 1 or 2. So that means there's only 2 ways that that could happen. And in our dice, right, that single divide, the die comes up 3. How many ways are there for that to happen? Well, there's really only 1 way to get that to happen, right? So we're just counting the ways in which a certain thing can happen. So we say, well, what would be the ways that we get event not A? Well, not A means that it's not even. And so, well, what do we say? Well, there's 3. There's 3 ways in which it can be not even. That is, there's 3 odd. Right? We think of this as just being the odd outcomes. That's another way of stating it. How about A and B? So let's see. The number of ways in the event that A can come up. Well, there is some overlap here, right? And if we think about this, there's our Venn diagram right here, right? Because there are 3 ways in which we can come up with an even, and there are 3 ways in which we can come up with something 4 or more, but there's really only 2 ways that we can have both, right? 2 ways, because that means that we would either get a 4 or a 6, right? There's only 2 even numbers that are also greater than or equal to 4. Right? So there's only 2 ways here. Let's see, how about B or C? Well, B is that there are 3 ways that we come up 4 or more, and event C in which we can come up with at most 2. Well, if we say B or C, that there's really 0 ways that that could happen, right? And that's always possible because we say, well, there's only there are 2 ways that we come up with at most 2, but if the event is that 4 or more, right, there's 0 ways in which this could happen. So there are, let's say if we say one or the other, well, there's no ways that they can be in common, right? They can be both. So actually, I'm wrong about that, aren't I? Yeah. No, there are 2 ways here that could occur. 2 ways to get a dice that is 1 or 2, and 3 ways that we can come up with 4 or more. So there's actually a total of 5 ways that could happen, right? Right. Now, this is a little bit different, right? Because I fooled myself there for a minute. I was thinking, well, what if it were B and C, right? Could we get that to happen? Well, this is the one that would be zero ways, right? Because they don't have any common event. And that's a different question. Nothing in common there. All right. All right, and we would call those kind of events mutually exclusive, right? Two or more events are mutually exclusive if no two of them have any common outcomes. So we think about two mutually exclusive events where there are events that have nothing in common, right? Events A and B are just simply separate, right? The common outcomes must be something else. By the way, this could happen with three events at a time, right? A, B, and C could all be mutually exclusive. A, B, and C could all have things in common, or if just two of them had something in common and the third group did not, we would still call that mutually exclusive with those three events. And let's go back to our dice right here, right? Let's ask, are events A and B mutually exclusive? Well, that would mean if they're mutually exclusive, that events A and B, the dice comes up even, or the dice comes up four or more. No, they're not mutually exclusive, right? Because there are two dice that are even and four or more. So they're not mutually exclusive, right? They do have overlapping events. How about events B and C? Well, we just talked about that, right? If the event is that the dice comes up four or more, or if the event, dice is at most two, right? These are mutually exclusive for sure. How about A, C, and D? Well, yeah, those are mutually exclusive again, right? Because there's no way that we could have a dice that comes up at most two and be three, or be at most two and come up four or more, or even be three and come up at four or more. So these are actually mutually exclusive events. Well, there we go.